This is the topic finding the intercepts, asymptotes, domain, and range from the graph of a rational function. Okay, let's see what we got here. Here's our first one that we're going to do. It says assume all asymptotes and intercepts are shown below and that the graph has no holes. Use the graph to complete the following. Okay, so first off is the asymptotes. So they are emphasizing the asymptotes with these dotted lines. So the vertical line is, of course, the vertical asymptote. And you may need to kind of zoom in to see it real clearly, but it's at x equals -1. So we just have that single vertical asymptote. For this one, x equals -1. And if you don't type the x equals, they will count it wrong. That is an important part of the answer because you're writing the equation of a line. You're not just writing a value. And then for horizontal asymptote, that appears to be right on the x-axis. And so the equation for that is y equals 0. Okay, so that's asymptotes. So it looks like intercepts are next. Intercepts are where we actually touch the axis. So I'm going to look at the y-intercept first because there's at most always going to be one y-intercept. You can't have more than one y-intercept on a function. Also, for these particular types of functions, just by the way, you could have more than one vertical asymptote, but not more than one horizontal asymptote. Okay. Anyway, so back to intercept. So it looks like we cross the y-axis right here. So we have a y-intercept, and it appears to be at 0, -3. And I believe that was a choice, so that makes me feel good. And then so let's see for the x-intercept. So it's possible to have none with x-intercepts as well, but I think, well, actually it does kind of look like there's none. It's hard to tell. I'm going to zoom this in a little more. So zooming in, it looks like this thing never actually touches the x-axis, and you could be forgiven though for being like, well, it looks like it just kind of sits on the x-axis kind of at the edges, but that's really the asymptotic behavior, the horizontal asymptote sort of sucking the graph towards it. So it never actually crosses it. So I'm going to put none. And then finally we have the domain and range. So the domain has everything to do with your vertical asymptotes. So that's somehow going to come into play. So in this case, it looks like we have, looking from left to right, we could have a point at any x value except right on top of the vertical asymptote. So everything except -1. And it says we need to do interval notation. So -infinity to -1, union -1 to infinity. Okay, so then range is often based on the horizontal asymptote, and in this case that does kind of act as a barrier. And so it looks like there's nothing above the x-axis. So it looks to me like the range looking from from bottom to top would be -infinity up to 0. But since we never actually touch the x-axis, we would not include 0. So it's going to be all parentheses, -infinity to 0, and then remember there was nothing up above, so that's it. Okay, let's look at another one that's a little different because it has a couple of more vertical asymptotes. Okay, or actually just one more vertical asymptote. So this one's going to be just a little more complicated because it has multiple vertical asymptotes. It looks like it's x equals -2 and then x equals 4 for the vertical asymptotes. And remember, -2, you have to do x equals, right? You're not just listing values, you're writing down equations of lines. And then yet again, we have the x-axis, or y equals 0, for our horizontal asymptote. And then they ask us about domain and range. I don't know why they mix it up, but we can go ahead and do that, I guess. Okay, so domain, it looks like it's everything except our vertical asymptotes, and that's always going to be the case with this topic. So domain is going to be leave out -2, leave out 4. So we're going to have kind of a bunch of intervals. So negative infinity to -2, union -2 to 4, union 4 to infinity. And then the range is going to be quite different from the previous one, basically just because of the middle portion. So even though some parts of the graph are kind of bounded, looking from bottom to top, the middle portion is going from negative infinity to infinity. And so basically somewhere on the graph, you have a y value of anything you want. Like if I picked y equals -78, there's a point that has that y coordinate. So the range for this one is negative infinity to infinity, even though some parts of the graph don't reflect that, right? You have to look at it as a whole. Okay, so then finally x-intercepts and y-intercepts. X-intercepts are where we cross or touch the x-axis, and it looks like there's only one of those. It appears to be at 3, x equals 3. And so this guy right here. Y-intercept, we can have at most 1, and it looks like we do have 1, and that's at y equals 2.